Hello everyone, welcome back to my tutorial. In this tutorial, we are going to solve this truss problem using Salome meca. It has a material of Young's modulus with a 210 gigapascal and Poisson ratio is 0.3, and all the links are having a cross section of 0.1 into 0.1. Now we will model this using Salome meca. Go to geometry, new entity, basic, point. First we will model point, from that we can develop into line. From point 1 to 2 it has a distance of 3 meter. First we will create first point 0 0, and next point is next distance 3 meter. Just apply. And next is a 6 meter 9 12, the meter of 6. From here to here 3 meter, just apply. 9, just apply. 12, just apply. Now we have created 1 2 3 4 5 points. 5 points we have created. We just want to create 6 7 8. So x is 3 now, y is also 3. Just apply. Now x is 6, y is 3, just apply. Then x is 9, y is 3, just apply. Now we have created all the points, then close. From the points we will develop a line. Go to line, first point, and see, yeah, second point, just apply. From here to here, just apply. From here to here, just apply. We will hide this one. Then from here to here, from here to here, just apply. From here to here, just apply. From this point to this point, just apply. Now we just want to go this point to this point, just apply. Now again go to this point to this point, just apply. And to this point, just apply. To this point, just apply. Now from this point to this point, just apply. Now from this point to this point, just apply. Finally we just connect these 2 points. So this is this truss. Just check. There is a triangle we just want to connect. Then not this line. This line you just delete it. Delete. Yes. Instead of this line we just want to put a line from the bottom. So go to new entity, basic, line. From this point to this point we just want to put like this. There is a true triangle, just connecting. Yes. Now we have created the truss. From the lines we will build wire using a build option. Or we can go for compound also. just so only. Then we'll create a groups to apply the boundary condition. All are having same beam, same cross section. I'm just giving a single beam group. Then point, here you can see the first point and fifth point. The first point is a roller, just apply, and the fifth point is the fix. I'm just giving fix, just apply. Then we just want to apply a force in 2 points, 2 and 3, force 125, force 100 in y direction. So select this point, just add Fy 125, just apply. Then this point, just add Fy, the name of 100. To easy understanding, I just naming like this. Whatever the name you can give it. Just apply and close. Now I have created all the groups for fixed boundary condition as well as the load. Now we can save this file. I'm just saving it here. Now we can go for mesh module to create the mesh. Go to mesh, select this compound, mesh, create mesh. Wire discretization and hypothesis local length. I'm just giving 0.3. Just say OK and apply and close. Right click this mesh one and compute. Now we have created 150 edges and 145 nodes. To see the nodes and edges, this way we can see it. Just close. Now we can go for efficient to generate the setup. I'm just opening the efficient. Analysis type is a beam element. Material is a carbon steel. 210 e power 9. Poisson ratio is 0.3 and this one is 7860. Assign to all. Just add it. Go to element type, beam element having a cross section of 0.1 and then 0.1 is assigned to, just go here, the group in the beams, small beam, just type beam. Now it is done, just add it. Go to boundary condition, node group, any name we can give. I'm just giving fix, assign to, here you just go here, small fix, fix, just arrest all the degree of freedom, just add it. And next one is the roller. Here we just set the name, all are in small. Roller has to move in x direction, remaining direction has to be fixed. Free the x direction. Okay, just add. Now just go to load. It is a force on the node. Any name we can give, load 1 or load F1 is assigned to Fy underscore 125, capital F small y underscore 125, in y direction minus 125. Check, this is in Newton only, so now we have typed 125 Newton, just add. And second is load Fy2, any name we can give. I'm just giving a name of Fy under 100, capital F small y 100 in y direction, minus 100 is the force value. Just add it here. Now just go to output, add all, save the command file, go to pictures, code aster, I'm just saving as static.comm. Now command file is written, just exit. Now we can open the command file. So start reading the mesh. Model destination is the beam element we have taken. Element property of defined, material property of defined, assign the material property, fixed group, roller support boundary condition, first load, second load, and solver is a meca static, and output file, saving the output file. Now everything is correct. Now we can run it. First we'll export the MED format, just save it. Now just go to aster, run astk. First locate the file. This is the location. Now I'm just saving this file. Just OK. Now we can create the files. First one is command file. So I'm just keeping right side this, and this folder I'm left side. Now first one is the command dot slash. This is static.comm, and second one is the mail mesh1 dot slash mesh underscore 1 dot med. Third one is a message file dot slash message dot mess. Fourth one is the error file dot slash err dot err. And fifth one is the resu file dot slash resu dot resu. And finally fifth one is the rmd file. This is the output file format dot slash result dot rmad. Now everything we have set up, created. I'm just specifying some 1 GB memory. Now go to interactive follow-up, just save this file, run it. Now it is solved and results also saved. You can check the message file first. Alarm and no errors. Now we can open this result file in paraview to do the post processing. Just go to paraview, just open it, pictures, code aster, rmd, just apply, and here displacement. This is the displacement, x value. Now we can see the deformed shape. Just apply. So this is the way it will get bent. Now we can animate it also. I'm just changing this color to blue to red, and this is I'm changing it to gradient background. Now we can visualize it little bigger. Now just go here, create animation, just OK. Now just animating, just have a look. So here we are given a roller support. Yes. This two node we are applying force, so it's bending like this, and this roller support is moving. So this is the way it will deform. So we can remove this animation track. Instead of much more scaling, we can give some little scaling. Create animation, some 15 frames, just OK. Now we can animate. So now it is okay. Now just go to stress. This is the normal stress in the members. These two are having a maximum stress of 1. These blue members are getting more stresses, but that are in compressive nature, and the red members are the tensile nature. So this way we can see the stress value in truss element using a Salome meca. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.